Hi everybody, good afternoon. We are presenting today our paper Agentic AI for Maintenance, Integrating LLMs, MCP and RAG. On behalf of our team, I am Stanley.dcruze. Our team members are Peter Fong and Rickard Sohlberg from Maladalen University. Now let's start with the problem that we are facing in the industry today. Finding the root cause of a machine failure sometimes very hard for the repairman to find out because the information and the knowledge is scattered all over silos. For example, CMMS manuals and other logs and mails and other documentations. So that's why it is not easy for repairman to try to fix and get the information why the root cause is there for why this is happening too often. So our system will make it easier to find the root cause and solution for the repairman to solve the problem. Our system consists of the three frameworks, that is agentic reasoning, which includes LLM, and the second is the RAG vector database, which is RAG is a retrieval augmented generation, and then the MCP integration. The most powerful is the agentic reasoning and the MCP, the which we will describe later. And now we will say why agentic system is better than other system, because agentic system using system to thinking, which is deep reasoning and deliberation of information from the RAG database, and also the reasoning power and the planning and action ability of the agentic AI makes our system more powerful. Now, for the methodology part, we have taken a dataset which is aircraft historical dataset, which has more than 6,000 rows and 3 columns. If you see the columns, maintenance users, maintenance operator or technician wrote the problem and the action, how they have solved the problem. So that is the main thing, and it is a textual based CSV file which is full of text. So this is the dataset we are going to use for our application. And so the first layer, if we remember the three layers we have, the first layer, if we consider the RAG ingestion layer, so we take that raw file, CSV file, and we convert it to MD file, .md file, markdown file, which is better for hierarchical search and the semantic similarity search of the vectors. And then we embed it with a model which is Cohere Embed English model, which is 1200 dimensions of embedding of vectors. And then we put it into a vector storage, which is Quadrant, and which is an open source and very good for similarity search. And then the second layer, we talked about, or we implemented the MCP, the RAG or vector database that we have implemented in the first layer. We connect it with our MCP server, which is called the USB-C of AI. So any AI applications, you can use the MCP, and you can connect nodes and tools of different inside or outside your organization. So rather than hard coding it, and you connect it with your agentic AI in the left. And the third layer, we have used the AI agent for our agentic system. We have used only one AI agent in this case, but we would like to mention that the possibility of more AI agent is to to integrate here is possible. So in our agentic AI, we connected with few nodes. Among them are uh, our maintenance grounded data and Google Calendar, emails, and also an AI. Our AI agent has a very good prompt where it says only answer from the knowledge base in the vector database, not outside that. And also, of course, the and LLM that should be of course used. So this is our system, and if we consider why our system and its level of autonomy and control, and we see that our system is level 1, which is a supportive tool and a suggestive tool, and also level 4, it goes with level 4 of supervised autonomy, because it can automatically do the action, and if necessary human intervention can be also be used. So this is the interface that we our system looks like, and you can integrate it in any front end of your organization, and then it is chatbot system which with the deep reasoning and can mail and book your Google Calendar repairman's Google Calendar. After developing the AI system, we need to evaluate the system, and evaluation is very crucial for any kind of research. And aircraft maintenance engineer is very hard to find because of their time and work pressure. So we have used another methodology called LLM as a judge. In this LLM as a judge methodology, we have used 15 rows and columns of questions and reference answer, which we call it as a ground truth. And then this ground truth will be used for our judge LLM as a judge architecture. So when user ask a question, AI agent gives an output, and also we try to match and or evaluate the ground truth and the AI agent, and then we evaluate those in 3 categories: correctness level, helpfulness level, and string similarity level. So here is the N10 of the evaluation that we have done in our evaluation process, connecting the LLM as a judge with our AI agent. And this is the one of the test result row from the evaluation run. So we have 15 rows, as we remember, we have 15 rows, and this is one of the rows, and giving the after the result it gives how what is the score. Like here it is correctness, helpfulness, and string similarity. Now here is the evaluation run, how we have run the result. And to get this table, we have run 5 runs with different AI agent model and judge model, and each run having 15 rows of our ground truth. So from here we have seen in the analysis part, we have seen that run 3 has the best performance with AI module, AI agent model is Claude Haiku 4.5, and Judge LLM is GPT 4.1. And then the DeepSeek run 5th has also the good performance with DeepSeek AI agent model and GPT 4.1. And another analysis is string similarity versus quality. Although the string similarity is very small, but it shows that strings without string matching, the correctness and helpfulness also is high. So that is why we could say that it does not rely on the strings matching words. It's depending on the semantic similarity. So this is how we like to conclude our paper and the future direction, what we want to go in future. And we would suggest that if this AI framework is used in industrial maintenance, we can improve the decision making and reduce downtime, and for the and also it gives a good reasoning and maintenance support for the repairmen and engineers. And in future we would like to use more embedding models and to see how the difference and the other vector database. There are many open source vector database are there, and also proprietary database. So we can also use it and compare it. We have not done anything comparison in this. We just in this paper, and also we wanted to fine tune with the fine tune the judge model with the maintenance ontology, and we need to build the ontology too. So thank you very much for listening, and this is our contact. If you have any question, please feel free to contact us anytime. Thank you.